Welcome. This video is to help you simplify algebraic expressions. I want to start with an example with a numeric expression because I want to start with something that you already know. If we were asked to simplify 5 times the quantity of 10 minus 1, we would simply follow something called the order of operations. You might remember it as PEMDAS. That's our memory cue. So the P in PEMDAS stands for parentheses, so I know that I have to perform operations within parentheses. I would simply work with 10 minus 1. We know that it's 9, so I'll bring down 5 times 9, we end up with 45 for our answer. When we work with algebraic expressions, things get a little bit different, because if I try to follow order of operations, I know I would have to perform operations that occur within parentheses. However, I now have an unknown. It's a little difficult to add 6 to an unknown value. So instead, we have to use another property about numbers, the distributive property. If we look at the English definition of the word distribute, it means to give shares of something or to deal out. So when we work with this distributive property in mathematics, we're simply dealing out something to something else. In other words, this is 3 times the quantity, this grouping, of x plus 6. So I'm going to be dealing out that multiplication by 3 to each term in those parentheses. So if I grab my pen, I can show you what's going on here. So I'm just going to deal out that multiplying by 3 to the x. 3 times x I can simply write as 3x. I don't know what that product is, so I just need to represent it in that way. And I'm also going to deal out that multiplying by 3 to the 6. 3 times 6 is 18, so I'm going to still have a sum, but now instead of 6 there is an 18 here. From here, I can't simplify any further because, again, we don't have like terms. Like terms are terms that have the same variable raised to the same power. Here I have a 3x. Here I have just a constant 18. I can go no further, so this is my final answer. Okay, so I want to take you through a couple more examples. Well, these are still single numbers times a binomial, 2 terms. So my first problem here is -5 times the quantity of 3x plus 11. I'm going to distribute that -5 to the 3x. -5 times 3x will give me -15x. And if I want to, I can bring down my addition sign. And then I'm going to distribute that -5 to the second term, the 11. -5 times 11 will give me -55. I like writing mine in parentheses. When we simplify an expression, we want to make sure that we're writing our final answer in simplest form. I don't like that we have a plus -55 here. There's a simpler way to write it. Adding a negative is the same as just plain old subtraction, so I can write it this way. 15x minus 55. Again, mathematically, these are the same thing. However, there are fewer operation symbols in here, or it's written in a more simplified format. So this will be my final answer because, again, I don't have any like terms to combine. When I do this next problem, I'm going to try to skip this step altogether and go right to the most simplified form. So this original problem is -4 times the quantity of 6x minus 2. I'm going to distribute my -4 to 6x, and I'm going to get 24x from that product. And here I'm going to distribute -4 to 2. I want to keep in mind that this is a minus 2, so the way I think about it is -4 times -2, because I can write it this way. -4 times -2 is going to be positive 8, so instead of writing minus a negative, I'm just going to write a plus. There we are. What happens as problems gain complexity? Here I have 1 plus 4 times the quantity of -3x plus 2. I want to distribute first. Just like order of operations, I want to make sure I'm taking care of parentheses, because if terms are grouped, I'm not going to be able to work with them or combine like terms. So I'm going to distribute first. Since the 1 has nothing to do with the distributive property problem I have over here, I'm just going to bring that down in my original problem. Now I'll distribute. So I have 4 times negative 3x. That gives me negative 12x. Again, instead of writing plus a negative 12, I'm going to write minus 12x. Now I distribute my 4 to the second term, 2. Positive 4 times positive 2 is equal to positive 8. Unlike our previous problems, I'm not finished yet. If I take a look at the terms that I have left, 1 minus 12x plus 8, I notice that they're like terms. So I see a 1 that I can combine with an 8. I will not be able to combine my minus 12x with these two terms because, again, this has an unknown in the term while the other two terms are just constants. So I can't combine a variable term with a constant. So as I'm simplifying, the second thing I'm always looking for is whether or not I can combine like terms. So I'm just going to bring down my minus 12x. I'll write it as negative 12x. And again, I have 1 plus 8. That gives me 9. Now that I no longer have any like terms, I am as simplified as I can get with this problem. That's my final answer. One final problem. This tends to be a problem where students make mistakes often, and it's when we're distributing. The reason being is because I have subtraction right before my distributive property problem. So I'm going to bring down my 3x just to start. And I know I have to distribute, but again, I have a minus here in front of my 6. I'm going to change it into plus a negative. So I need to actually distribute a negative 6 to the two terms inside the quantity. That's very important. So I distribute my negative 6 to my positive 7. Well, negative 6 times 7 gives me negative 42. So I'm going to write minus 42. Next, I'm going to distribute the negative 6 to my 5x. Again, I'm going to keep in mind that there is a minus sign in front of my 5x. I can think of that as plus negative 5x. So a negative 6 times a negative 5x will give me positive 30x. So I write that as plus 30x. From here, I want to see if there are any like terms. I notice that there are two variable terms in the problem. I see a 3x and I see a 30x. So 3x plus 30x will give me 33x. This constant term, minus 42, just needs to be brought down with the rest of my problem. I had nothing to combine it with, and I'm finished here.